methods, we can look at question 10 from exercise 2H. So we've got a worded problem and it's through simultaneous equations. So we've got dA and dB to represent cyclist AB traveling along a straight road. Okay, and the distances traveled is given by these two equations, where time is in hours after 1 p.m. Okay, so when t equals 0, that's 1 p.m. When t is 1, that's 2 p.m. T equals 2, that's 3 p.m., etc., etc. I want to sketch each of the graph on one set of axes. Okay, so you're going to have to draw a graph, and your y is like your d, your distance in kilometers, and your x is like your t. Okay, before I even draw the graph, it's always important to check where the intersection between the two graphs are, because if I look closely, I can see the gradients are the same. So I'm expecting them to cross at some point. All right, so this is what you do when you solve for the equation. So we've got d equals 10t plus 15, and d equals 20t plus 5, and we're trying to find where they intersect. I'm going to use the substitution method. So can you see that d equals this thing? Now, what if I sub d into this d? So I sub this equation in for d. So I go 10t plus 15 equals 10t plus 5. And when you solve that, what that gives you is what at what t value the intersection occurs, or they're the same. So I subtract 10 off 10t off both sides, so I get 10t left on the side, and then I subtract 5 off both sides, so I get 10 left on the side. So t would equal 1, okay? Now, I'm not finished yet. I want to find the corresponding d coordinate, okay? So I sub into either one of the equations. I'll just sub into the first one. So d equals 10 times 1 plus 15, so equals 25. So your coordinate of intersection is t equals 1, d equals 25, or in coordinate form like that. Now, why is that important? Because in order to draw the graph, I want to get an idea of scale. First things first, I need to point the y-intercept. The y-intercept is this, or known as d-intercept in this case. So we've got 5 and 15. Now, we know that this graph, dB, is increasing at a faster rate than dA. So it's going to overshoot, because the slope is steeper, it's going to overshoot the slope of dA. So it's going twice as fast. So you're going to have an intersection like this. And we can label this intersection because we know it's 125. Okay. Now, you notice I don't need to draw a huge scale. It's just that I got to make sure my graph is relatively accurate. Can you see that my 15 and 25 aren't really aligned? So I got to make sure my scale is good. Okay, so let's try this again. So if that's 5, I might get rid of the 5 here. So let's do this again, just to make sure it's proportional. So that's 5, that's 15. And that's going to increase at a steady rate, faster rate, and increase at quite a fast rate. And this is increasing at a slower rate. So here would be 125 like that. And part B is basically asking you to find the point of intersection. So find the time in hours which the two cyclists are the same distance from the step ball. So same distance means point of intersection. So find the time in which this occurs. So part B, this is part A. Part B would be after 1 hour. So that would be at 2 p.m. Okay. So hopefully that helps. Now, if I want to do this on the CAS calculator, all I need to do is you can solve this simultaneously. So I'm going to use a simultaneous tool. Yep, simultaneous tool. You can go y equals 10x plus 15, and y equals 20x plus 5, and I solve for x and y, and as you can see, you get the same answer. Okay, so there's two ways to do it. It's up to you, or you can even do it on the graph if you want. So hopefully that helps.